Okay, let's keep going. So, we know that if we're dealing with a triangle, whether it be vectors or whatever, we can use our trig function. Another important item to remember is that if we have some vector and it's on an angle, we can break it into its x and y components. We can call this vector in the x direction, and that's going to be in addition to vector in the y. Okay, so now we've made this right triangle that we can use all these trig functions on. Here's our trig functions, and then here's how they relate to the angle. Okay, so if you're unfamiliar with these, please take a moment to read through these and make sure you're understanding that. We're going to use it quite a bit. Okay, so if we have v here, and we know we can break that into v sub x and v sub y. Okay. We can use Pythagorean theorem. We can say that v is equal to the square root of v sub x squared plus v sub y squared. Okay. Now, if sine of theta is equal to opposite over hypotenuse, we can use this to solve for v sub y. And the way that we do that is we multiply v to both sides. So this magnitude here, v multiplied by the sine of theta, that's going to equal v sub y. Similar concept here, cosine is adjacent over hypotenuse. But if we want to know that adjacent, that v sub x, we'll multiply the magnitude of the hypotenuse to both sides. So v times by the cosine of theta, theta is going to equal v sub x. Okay. Now, if tangent is opposite over adjacent, we can take the tan inverse of opposite over adjacent, and that will tell us theta. Okay, and we're going to be using each of those. Okay. So we're going to take some vector A, and we're going to add it to some vector B. Okay. Now, when we're working with this, there's a couple different ways that we can look at these kinds of practice problems. I want to try both ways. So let's see, first off, I'm going to say that we have a vector with magnitude 5. We're just going to leave these unitless for the time being. Could be newtons, it could be displacement, it could be meters, kilometers, etc. And an angle of 45. Let's do a positive angle of 45 from the positive x-axis. Okay, and then let's make this a positive 35 from the negative y-axis. Okay, so I want you to add those to your notes. And then we're going to look at another question, and we're going to look at it a little bit differently. So, if we have positive angles, it's important to remember that when we're going counterclockwise, we call that a positive degree direction. And then when we go clockwise, we call that a negative degree direction. So if we're going positive 45 degrees from the positive x-axis, well, here's the positive x-axis, this is the negative x-axis, and we're going to go a positive 45. Well, positive is this way. So I'm starting at my x-axis, I'm going to go this direction, but I'm going to go 45 degrees. Okay, so we have, I don't know, magnitude. Okay, so we have vector A, which has a magnitude of 5, and it's a positive 45 degrees from our positive x-axis. So here's positive y-axis, here's negative y-axis. So if I'm starting at negative y-axis, I'm going to go positive 35. So again, positive degree direction. Okay? So if I'm at my negative y, I'm going to go positive degree direction 35 degrees. This is bigger. This is 7. I need to make that proportionally larger. Okay. And then this is 35 degrees. This is vector B, and it's 7 units, whatever units we're going to be working with. All right, now we want to add these two vectors, which means that we want to find the resultant of those two vectors. When we did this before, we made a list. We said that we can take a sub x, a sub y, b sub x, and b sub y. Okay, and then we can add those together to get our resultant, or our c in the x direction and our c in the y direction. Okay, we just called it, we're doing c as our resultant. If we want to, and maybe we could change that now, we could just call it r instead. It's our resultant of the two. Okay, and then we had just the whole component of r, not the x and y components. And then after that, theta. If we follow this list, then we're able to work our way through this. So let's look at A. A can be broken up into its x and y components. This is a sub y and a sub x. Okay, so reminder, if we're looking for a sub x, in this situation, it's adjacent. And so when we have adjacent, we're going to use cosine. Okay, and so cosine of 45 equals adjacent, which is a sub x, divided by the hypotenuse, which is 5. So do you see how I can multiply both sides by 5? And then that tells me that a sub x is equal to 5 cosine 45. Okay. Now, a sub y, y is opposite. So instead of cosine, I'm going to use sine. So it's going to be 5 sine 45. Okay. So 5 times by the cosine of 45, so 3.5. Okay, and then because it's 45 degrees, if it was anything else other than 45 degrees, this wouldn't be true, but because it's 45, those values are the same. Okay, so they're both 3.5. Okay, now for B, we have b sub x and b sub y. Okay, so b sub x is actually our opposite component from the degree. So we're going to use sine for b sub x. So we'll take the hypotenuse of 7, and then we're going to go sine 35. Okay, and then b sub y is adjacent to the angle, so it's going to be 7 cosine 35. Okay. All right, so I'm going to multiply those. So I'm going to take 7 times by the sine of 35, and that gives me 4.0. And then I'm going to take 7 times by the cosine of 35, and that's going to be 5.7. Okay, wonderful. Now, at this point, we need to slow down, hit pause, and decide, are these values positive or negative? So if this is positive x and this is negative x, do you see how this a sub x is in the positive x direction? So that's going to stay positive. Now same with y, y in the positive, y in the negative. So a sub y is positive y, so that will stay. Now, b sub x is in the positive x, so that one will stay, but b sub y is in the negative y, so that's going to change to negative 7.5. Now, reminder, we're finding the sum of the forces here. So if I were to take A and pick it up and place it down here, okay, I'd get some resultant which is down over here. Okay, so I want to draw that. I want to show on a separate, I'll do it right here. Doesn't need to be big, but I just want to show that I'm expecting my resultant to be somewhere over here. And I'll call this theta. And this is going to be r sub y and r sub x. Okay? Alright, now, here's how we figure out r sub x. You take a sub x and you add it to b sub x. So a sub x, 3.5, added to b sub x, 4.0. So we get 7.5. Okay? And then to get y, we take a sub y plus b sub y. A sub y was 3.5, and then we're adding to the negative 5.7. Okay? So we're going to take that 3.5, and we're going to add that to the negative 5.7. So that gives us a negative 2.2. And this should make sense. Like, here's our 7 in the x, positive, and then we have a much smaller negative 2.2. Okay? Well, here's our triangle. A squared plus b squared equals c squared. Let's use Pythagorean theorem to figure out r. So that's just going to be the square root of r sub x squared plus r sub y squared. Okay? So here's the square root r sub x. Now, if you're going to plug in the negative signs, you need to do a double set of parentheses, like I've been doing, or you can kind of go through and reason that this is a magnitude, and that if I put negative 2.2 squared, that any negative squared, it's just negative 2.2 multiplied by 2.2, so that's going to give us a positive. So you can decide how to look at that and either plug in the negative with the parentheses. It doesn't work well without the parentheses. Okay? So we have 7.8. Okay, awesome. There's the magnitude of our resultant, and then the last thing we need is theta. Remember that tangent theta is equal to opposite, which is r sub y in this situation, over adjacent, which is r sub x. So theta will equal tan inverse of r sub y over r sub x. Okay? Alright, so we're going to plug that in. So we're going to take tan inverse of r sub y. And again, this is a magnitude, so I'm just going to take 2.2 divided by r sub x, which is 7.5. Okay, and we get 16 degrees. Okay, so it's a lot of steps, but it should be review. We're just looking at if we have this vector and this vector and we add them together, then we're going to get some kind of resultant. Here's the magnitude of that resultant, and here's the angle of that resultant. Okay, when you come back next time, we're going to look at another practice problem just like this, but we're going to move from axes to a different view.